Here we introduce terminology, orthogonal. When we have two vectors, we say the two vectors are orthogonal if their dot product equals 0. So what does this mean? Orthogonal is really just another way, fancy way to say perpendicular. Okay, so if you think about this, we know u that v equals length of u times length of v times cosine theta. So now, if u dot v equals 0, what does that mean? It means the length of u times the length of v times the cosine theta equals 0, right? Because they usually the same number. All right, so this is non-zero factor, this is non-zero factor. So if three things multiply together, these two are non-zero, then it will force cosine theta equals 0. And we know cosine theta equals 0 when theta equals a half pi 90 degrees. So that's this. When theta is equal to a half pi, we know that vector u and vector v are perpendicular, but we tend to say they are orthogonal vectors. You have seen orthogonal vectors. So think about the standard unit vectors. So in R2, what do you have? You have vector I, you have vector j. And what that be? I is 1, 0, j is 0, 1. And you know that j is a vector along the y-axis direction. I is a unit vector along the x direction. So you know they are perpendicular, right? So that's just the fact that you know. And you can double check. I dot j is equal to 1 times 0 plus 0 times 1. That gives you 0. In R3, you have I, j, and k as your standard unit vector. So I is 1, 0, 0, j is 0, 1, 0, k is 0, 0, 1. And you can check any of these two vectors are orthogonal. So let's say j dot k. What do you have? You have 0 times 0 plus 1 times 0 plus 0 times 1. And that equals 0, right? Because 0, 0, 0. Okay. So you know that any of these two vectors are orthogonal. They are perpendicular to each other. So again, if we say two vectors are orthogonal, that means they're perpendicular. That means their dot product equals 0. So if I say I want to look for a vector that is orthogonal to a given vector, what does that mean? If, let's say, on R2, I'm given a vector u, and I want to find v that is orthogonal to u. What does that mean? It would be a vector that is, again, perpendicular to the given vector. Because it's R2, so I know it's either this direction, so that's a potential answer, or this direction, that's another potential answer. Okay? Or let's say in R3, if I wanna find a vector W that is orthogonal to a given vector U and a given vector V, then what does that mean? So let me erase this part. So that's saying R3, I have vector U here, I have vector V here. And I'm looking for something that is orthogonal to U and V. So let me use a 3D. So I have a vector U here, the black pen. I have a vector V here, the red pen. I'm looking for a third vector that is perpendicular to both of them. So think about this. If it goes like this way, okay, so you can see the blue and the black are perpendicular, but the blue and the red is not perpendicular. So this is not the answer. So I will keep the 90-degree angle between blue and the black and keep rotating it, so then the blue and the red are orthogonal as well. Okay, so for example, this could be my vector W. So in this case, the W could be, for example, this one pointing up or this one pointing down. Okay, they are both perpendicular. Both these two choices are perpendicular to vector V and vector U. Okay, we'll further go looking into this type of problems, but you still need to understand orthogonal is just a fancier way to say perpendicular, and algebraically, if the dot product of two vectors equals 0, then you know they are orthogonal. Okay?